Next, we're going to look at a couple of the hazards associated with thunderstorms, lightning, and tornadoes. And in case you were unsure, lightning is an electrical discharge that is produced during thunderstorms. This is the only time it happens. This results when opposite electrical charges develop in different regions of the cloud and on the ground. Those positive and negative charges want to close the circuit. Remember, positive and negative like to connect. They like to attract. When they do this, when they close that circuit, the lightning is discharged. And something important to remember, especially when you're trying to be safe getting away from lightning, is that lightning will follow the channel of least resistance. It's kind of like Mike the Tiger. It's super powerful, but it's also super lazy. So it's going to want to go to places like wet soil and travel along tree roots and so forth. Electrical cables loves them. When that lightning is discharged, it superheats the air to between 30,000 and 50,000 degrees Celsius. There's some debate about this, just how much, but as it supercharges and superheats that air, it does so pretty much instantaneously. So that heated air just, boom, rapidly expands outward. And that acoustic shock that happens as it does that, that's what we hear as thunder. Lightning travels in one of three ways. It can go first cloud to cloud, which is by far the most common. This is where an electrical charge builds up between clouds so that discharge runs from one cloud to the next, cloud to cloud. Then it could also occur within a single cloud. We can get that buildup of electrical charges within that one cloud so that lightning stays inside the cloud. Or it can go cloud to ground. This is the one that we're always impressed when we see it. That thing of lightning just like comes between the ground and the cloud, and it's just so impressive, but it's also really, really not that common. Despite that's the one that really stands out to you. But cloud to cloud is the most common way for lightning to travel. When that lightning does hit the ground in areas with a lot of silicate sand, which is basically what glass is made out of, that heat from the lightning as it travels through the ground can form these, it melts the sand and forms these glassy hollow tubes called fulgurites. Now think about where you find areas with a lot of silicate sand. Deserts and beaches, and this is where we will typically find fulgurites if we can find them at all. And we can look at a couple of quick examples of those different paths that lightning can take. This first one that we're looking at here, this is a 20-second exposure. It was taken over a period of 20 seconds, leaving the camera shutter open, of a lightning storm in Athens, Greece. And this one is showing both cloud to cloud and cloud to ground lightning bolts. You see the ones that go pretty much horizontally, those are cloud to cloud. And then we have a few over on your right, those are going cloud to ground. Only about 25%, like I said, of all lightning charges are actually cloud to ground. Here's another image of, I believe, that same storm in Athens. Oh, they do get a lot of lightning in Greece. But this is once again showing a little bit of both things going on. We have a little cloud to cloud lightning, and then we have some really cool, almost mirror image cloud to ground lightning bolts. This picture that actually is showing cloud to ground, or in this case, cloud to river, I believe was taken in Baton Rouge, and that lightning bolt is discharging into the Mississippi River. And I think we all know where this is. This is Tiger Stadium, lit up more than during that last Garth Brooks concert. What we're looking at here is an example of the fulgurite. These fulgurites are produced when heat melts the sand into glass as that lightning travels through the ground. This one we're looking at here is about 14 inches long, and it was found in Queen Creek, Arizona, in the desert. So what causes lightning? Well, we kind of went over that already. First, what you need to know is that lightning happens in cumulonimbus clouds. That's the type of cloud that will produce lightning. Why? Well, if you remember the cumulonimbus, those were those towering clouds that would go like from low level to mid level to high level. there was a lot going on in there. Remember, we had ice crystals forming at the top of the cloud, we had rain forming at the bottom of the cloud, and in between we had both processes going. Well, there's a lot going on there electrically too. We also have a positive charge in the upper atmosphere and a negative charge going on at the Earth's surface. When those opposite charges build up in those two different regions, they develop that electrical connection. That bolt of lightning is discharged and the sky lights up. So here's our towering cumulonimbus. You can see that we have those positive charges at the top of the cloud. We have the negative charges at the base of the cloud. We have positive and negative charges in the middle of the cloud. And then I said that the Earth is negatively charged. Normally it is, but when a thunderstorm is going on, positive charges can build up over the surface of the Earth, particularly in where the Earth is raised. Some object is up above the actual surface, like a tall tree or a tower or something. And here you can see that cloud to ground lightning example. We have the positive charge down towards the Earth's surface. That is sending up a positive charge from the Earth's surface upward. And at the top of the base of the cloud there, we have a negative charge. Remember, we're talking about the cumulonimbus clouds, and at their base, they were negatively charged. So that negative charge is traveling down towards the ground. The positive charge is traveling up towards the cloud. They form that connection, and boom, we got lightning. Here is another really pretty stunning example of cloud to ground lightning. That lightning is heating the surrounding air to 50,000 degrees, and I'm assuming they mean Fahrenheit here, or 5 times hotter than the surface of the sun. That extreme heating causes a rapid expansion of air. As it expands outward, it causes an acoustic shock, and that is what we hear as thunder. But why do we see the lightning before we hear the thunder? Well, it's pretty easy actually, because light travels much faster than sound. And that light reaches our eyes almost instantaneously compared to the sound waves that travel to our ears, because they just take longer to get there. We'll get back to the more common types of lightning in just a second, but I wanted to take just a minute here to look at some extremely rare but very interesting phenomena that occur during really very, very powerful storms. These are things called elves, red sprites, and blue jets. So first off, we have elves. Really strong thunderstorms and lightning storms can sometimes produce this huge disk of red light that we call an elf in the thermosphere. And these happen at about 100 kilometers to 62 miles in altitude. Red sprites form above the top of the thunderstorm and can tower 80 kilometers or 50 miles above the top of the thunderstorm. Mind you, that's not over the surface of the Earth, that is over the surface of the thunderstorm. And then we have blue jets. These are blue electrical discharges that sometimes burst out of the top of the thunderstorm like fireworks and climb up into the stratosphere. None of this will be on your exam. It's just very cool for your information. I will try and find some more articles or videos or something about these and put them on Moodle for you in case you're interested and would like to learn more. But meanwhile, let's get to lightning safety. This is extremely important, for as awesome as lightning is, and as much as I like to sit around and look at it, while it is extremely cool to look at, it is not cool to experience up close and personal. It can kill you. It probably would kill you. It may not. People have been struck by lightning and survived, but often with really terrible and irreparable physiological and psychological damage, and they're left with a lot of severe emotional problems. Not necessarily from having a traumatic experience, but the lightning literally kind of scrambles your brain if it hits you. Bear in mind, it is also not true that lightning never strikes twice. There are numerous people who have been struck multiple times by lightning, so don't count on that. How do you know if lightning is getting close? Did you ever play the 1 Mississippi, 2 Mississippi game? You see the lightning and then you start counting until you hear the thunder. I think pretty much everybody's played that, but it's actually closer than what you get when you use that game. What you can do to tell how close the lightning is when you see that lightning flash, start counting. Count the number of seconds until the thunder. You can still do 1 Mississippi. That's a second about. But then once you've got that count, once you hear the thunder, divide that by 5, and that's how far away it really is in miles. If that lightning that you just counted on is within 5 or 6 miles, you need to get indoors and wait 30 minutes to go outside. What if you can't? Well, there are a couple safety rules. During a thunderstorm, you always want to shelter indoors if possible. If you're outdoors, don't be the highest object or standing under the highest trees. And if caught outside, inside a car is safest. Once again, wait 30 minutes after the storm has passed to go back outside. And here we have a couple of figures from your book just to help remind you of these things. If you are outdoors, you need to avoid either being at, or being near the tallest landscape feature. Do not climb a mountain during a lightning storm. I can tell you some interesting stories about your textbook author being out at the top of a mountain during a lightning storm. 10 out of 10 would not recommend. Do not go golfing during a lightning storm. Don't go play soccer. Don't go play football. Don't go stand under a tall tree. Don't be out on a boat on flat water. There's a lot of don'ts. If you're inside, then you want to avoid things that are going to conduct electricity, like landline telephones, electrical appliances, your computer. Don't mess around on your laptop when there's a lightning storm going. Just take a break, turn it off, and wait until the lightning has passed by. If you are caught outside and you have no choice but to take shelter under some trees because that's all there is, make sure you choose the shortest tree because lightning is going to want to go to the tallest feature it can find. If it is a possibility for you, the absolute safest place for you to be outside during a thunderstorm is to get in your car or somebody else's car safely. What's going to happen is that once that lightning hits the car, it's most likely going to be conducted through the metal frame of the car and down into the ground safely. It is not going to electrocute you. Now, bear in mind, this isn't a 100% guarantee. You are relatively safer in a car than standing outside. So remember, if you're caught outside, get in a car. It's your best bet for staying safe. Stay safe.